Those who are online are able to hear me. Those who are online are able to hear me. Shall we get started? So we discussed till 6th question, right? Yesterday. Yes. Let's see how to do the 7th one. Tell me. The lengths and radii of 3 wires of same metal. What do you mean by same metal? Very good. So wherever they say that it is same metal, then the first thing that you need to have in your mind is resistivity is the same. Right? So rho is same. Are in the ratios. So L1 is to L2 is to L3 are in the ratio 2 is to 3 is to 4. And radii are in the ratio R1 is to R2 is to R3 are in the ratio 3 is to 4 is to 5. Is that clear? They are joined in parallel and included in a circuit having 5 ampere current. Find the current in each wire. So these 3 resistors which have this specification are connected in parallel and they have 5 ampere of current in total which is flowing through each resistor, right? If that is the case, then how to find the current across each resistor? How do we even proceed? Okay. Okay. Remains the same. That's right. Okay. Okay. But you'll have 3 unknowns now. Okay. Is it necessary for us to find V? Do we need to find V? In this problem, is it necessary for us to find V? Is there any smarter way in which we can proceed? What you told is right. The approach is 100% right. But is there a smarter way where we can solve this? Your whole idea is correct. Do you want to find individual resistance is what my question is. Same material resistivity is same. If, what are the hint given in this question? Think about this. No, length is given, radius is given. So wherever they give us radius, what do we understand? We try to find the area of cross section. So R is equal to rho into L by A. So can I say potential difference across 1, 2 and 3 are the same? So V1 is equal to V2 is equal to V3. Can I call it as a constant? But what does Ohm's law tell us? V is I into R. So can I say I1 into R1 is to I2 into R, or I1 into R1 is equal to I2 into R2 is equal to I3 into R3, which is also a constant. Can I say this? So from this, I can say I is inversely proportional to R. So what is the job? To find I1, I2 and I3. So can I say I1 is to I2 is through I3 is equal to 1 by R1 is to 1 by R2 is to 1 by R3. Can I do this? So now you know how to write R1. R1 is rho 1 into L1 divided by A1. So 1 by R1 is to 1. So this will become A1 by L1 is to A2 by L2 is to A3 by L3. Is there any doubt till this? Am I clear till this step? We need not find. We need not find. That is what I'm saying. R1 empty individual. You see, according to the logic you told me, you wanted to find individually. But is it not a waste of time for us? So instead, we can go with the concept of ratio. Okay. So A1 by L1 is to A2 by L2 is to A3 by L3. So A1, what can I write? Pi is going to come because it's going to be a circular shape. So I can directly write it as R1 square. So R1 square 9 by L1 is 2. Is to repeat 16 by 3 is to 25 by 4. Is this right? So this is I1 is to I2 is to I3. So from this, how can you find is what the question is. Now you have ratios in hand. How will you solve this? So I can say I1 plus I2 plus I3 is equal to 5. So I1, can I write it as 9 by 2K? Because it is not 9 by 2, rather it is 9 by 2 times some constant. Is to 16 by 3 times K is to 25 by 4 times K, sorry, plus is equal to 5. Can you find out the value of K and tell me? So, but before that, copy all these steps. I hope you're able to understand, right? Those who are online, you are able to understand?
Yes, sir.
So once you come to the last step, do that mathematical part and tell me what is K. Okay. Yeah. What is the LCM base? 12. Fractional values. 60 by 193. 60 by 193. here. Okay, K is 60 by 193. 193 then. Up I1 evo 9 by 2 into 60 by 193. Up evo this will go 30 times. But 193 is it divisible by anything? Doesn't seem to, no? So how much is it giving us? It's giving us 270 by 193, no? 270 by 193 is how much? So how much is it? Calculate and tell me approximately. Correct. Tell me how much is it? 1.39 is what we are getting. So 1.39 is what is rounded off to 1.40. So what we did is right. Okay. So what I wanted to explain in this problem is going forward, whenever there are problems based on this kind of ratio, right? So for explanation part, I wrote all these things, right? So if it is for your board exam, better write these steps. If it is for your competitive exam, try to avoid them and do all these things in mind. So with practice, you will understand that when the product of two values is a constant, one value is inversely proportional to another. So even without doing, you should be able to know that. Am I clear? Did you understand what I told? Since V is a constant, V is a product of current and resistance. When product of two values is constant, one value is a reciprocal of other. It will be inversely proportional to other. Okay. So with that logic only, if you see the solution, that is the logic with which they started solving it. And they handled ratio in a completely different way. They took the LCM and multiplied with the common factor everywhere. That is why they got 54 is to 65 to 75. But since the total current is 5 ampere, if you look at the solution, they wrote it as 5 into 54 divided by 193. That is a way of solving, or I would rather call it as fractional value. Means out of the total current 5, what fraction is drawn across the resistor R1? That is why they wrote it as 5 into 54 divided by 193. Which will also lead you to give you the same answer. 54 into 5 or 270 then. It's the same logic, right? So this part is left to you. So otherwise, I hope the problem is clear, right? Shall we proceed? Read this question and tell me, give me an idea of how to solve. There is a dry cell of EMF 1.6 volt and internal resistance of 0.1 ohm, which is connected to a resistance of resistor of resistance RO. If the current drawn from the cell is 2 ampere, then what is the voltage drop across the resistance capital R, and what is the energy dissipation in the resistor? How do you find it? Yes, means you will read the internal resistance also as an external resistor and then find the value. Can you do that and tell me? Tomorrow is a holiday for everyone. 1.4, I think that is answer. 1 minute. I think that is answer. Second one 2.8. Yeah, 2.8. But actually, you would have calculated power, right? If I'm not wrong. There is a small mistake in the question. They asked what is the energy dissipated. They should have asked what is the rate of energy dissipation, because they didn't give you time. The energy is dissipated in the form of heat. So heat, what is the formula? I square RT. But they didn't give us time here. They didn't. So you can only calculate the rate at which the energy is being dissipated. You want water? Okay. Correct. So there is one way. So you guys solved using by finding the equivalent resistance, right? Is there any other way in which we can solve the same problem? So this is 1.6 with an internal resistance of 0.1 ohm and an external resistor is connected which has a value of capital R. Is that right? Is there a way where we can solve the same problem in a different way? So the cell is there, no? This cell, is it getting discharged or charged? Discharge means what is the potential drop across it? What is the potential drop across the cell when it is getting discharged? In terms of EMF and internal resistance. V is equal to E minus, you remember this? Okay, this is an alternate way. So the potential drop across this will be the same as potential drop across this. So V is equal to E minus IR, and the same E will occur across the bigger resistor also, the external resistor. Okay, so E minus I into small r will be equal to I into capital R. Now can you find it? So what did they tell us? Which implies 1.6 minus 2 into 0.1 will be equal to, how much is it? 2 into capital R. Okay. So can you find the value of capital? What is the value of capital R you got? 0.7. Okay. That 0.7 multiplied with 2 is what is going to give you the potential drop. So this is an alternate way. Is it clear, guys? Okay. So I wanted to establish this formula also. Okay. Be 1.4. So potential drop across capital R is 1.4 volt. Energy dissipation, please change the question as rate of energy dissipation. Rate of energy dissipation means power. So what is the value of power? Power is equal to I square into R. So 4 into R is 0.7, which will give you 2.8 watt. Okay, be specific with the unit. Unit missed, half mark lost. Okay. Shall we do the next one? Ninth one, see. There is a battery of EMF 3 volt and internal resistance small r, which is connected in series with a resistor of 55 ohm through an ammeter of resistance 1 ohm. The ammeter reads a value of 50 milliampere. The reading is 50 milliampere. The units are not given there. Then draw the circuit diagram and calculate the value of small r as well. Can you do that? So there is a battery of EMF 3 volt and internal resistance small r, which is connected in series with a resistor of 55 ohm through an ammeter. So how is the ammeter connected with respect to the circuit? In series or parallel? Obviously in series. Okay. So battery in a series of cells, internal resistance R. There is a ammeter which shows a reading of 50 milliampere, and the external resistor is of value 4. Okay. So did you, when you drew the circuit diagram, did you put this box around it? Did you? Yes. So this will be 3, this will be R, 50 milliampere. So how do you solve? Same logic again. So here it is 1 ohm, right? So how many resistors are in series? R plus 1 plus 55 is equal to, how much is it? R is equal to V by I. What is the potential difference supplied? V divided by I is 50 into 10 power minus 3. This is equal to 3 by 5 into 10 power 2. So 300 by 5 is how much? 60. So R will be how much? 60 minus 56, which is going to be 4 ohm. The internal resistance is 4 ohm. Is that clear? Is there anyone having doubt in this? R is equal to V by R. So R is equal to V by I. Yeah, shall I proceed? Can you try this? There is a 20-volt battery of internal resistance 1 ohm, which is connected to 3 coils of 12 volt, 12 ohm, 6 ohm, and 4 ohm in parallel, and a resistor of 5 ohm. So where is it? And a reverse battery of EMF 8 volt and internal resistance 2 ohm. Okay, as shown in the figure. Calculate the current in each resistor and the terminal potential difference across each battery. Can you do that? Yeah. Right. So there are 3 resistors in parallel. First, the equivalent resistance. See, tell me one thing: is it a simple circuit or is it a network where you need to go with Kirchhoff's law? You need to go with it. But I feel it's a simple circuit. So when will you go with Kirchhoff's law? When you have more than one cell, but for more than one cell, you're not able to find the equivalent EMF. But when will you apply Ohm's law? By looking at the diagram, how will you know whether I'm supposed to solve with Ohm's law or Kirchhoff's law? Kirchhoff's definitely complicated. Ohm's law should have one cell and one resistor. So is there a possibility where the circuit can be converted into one cell and one resistor? Yes, we can do that, right? So by finding the equivalent resistance across 12, 6 and 4, 2 other, okay, 12, 6, 4 is 2. Then every other resistor is connected in, including the internal resistor is connected in series or parallel? Series, okay. Now how are the cells connected? Cells are also connected in series, but how are they connected in series? They're in opposite directions. So when it is in opposite direction, what will happen to the equivalent EMF? They'll get subtracted. So the equivalent EMF is 12 ohm, 12 volt. Is there anyone who's not able to understand? So the equivalent resistance for this is 2 ohm. I am assuming that I need not solve this part. I hope everybody knows this, right? So 1 ohm, 5 ohm, 2 ohm, and 2 ohm, they are connected in series. So what is going to be the equivalent resistance? 5 plus 1, 6, 6 plus 2, 8. Sorry, I don't know. Just give me a minute. 10. And what is going to be the equivalent value? So equivalent value will be in this way. So when you're drawing the diagram, also draw it perfectly. Why am I drawing it like this? Why am I drawing it in this way? Previously, I drew it like this. Out of this way and this one, which one is correct? First, either A, either B. Which one is correct? B correct or A correct? Idua B. Confident as well. B correct, A correct. A is correct because where is the positive cell dominating? For 20 ohm, 20 volt. So A is the right answer. So you need to be very careful with the diagram because there might be a question where they'll ask you what is the direction of current. The particle anti-clockwise direction, it will go wrong. You're able to understand? So they can frame anything. So this is going to be 12 volt. Now what are they asking? Calculate the current in each and the terminal potential difference. So first, what is the total value of current that is flowing? I is equal to V by R, 12 by 10. So total current supplied is 1.2 ampere. That 1.2 ampere will flow through, without a doubt, 1 ohm, 5 ohm, and 2 ohm. Across all the three resistors, it is 1.2 ampere only. But that 1.2 ampere will get divided across the 12, 6, and 4 ohm resistors. Then how will you find it across them? Yes, potential is same. So we did something with ratio problem, right? Can you do something like that? Try to get your own formula for that. 0.65. But how did you do that? I'm asking how will you find it? Which is 22. Total? Total what is 22? Keerthana, you were saying something. Potential difference is the same. So can I say I1 plus I2 plus I3 is 1.2? Is that right? So I1 what can I write? But V by R, I'll be deriving the formula for equivalent resistance. V by R1 plus V by R2 plus V by R3. I'll write it as V by R. And V cancel it. I'll get the equivalent formula. Is there anything else that I can do? Okay. But I don't know the value of V, no. Okay. Yes. So what we can do is we know that the potential difference V is equal to I into R. What is the total current flowing through the equivalent circuit? 1.2 into what is the equivalent resistance? 2. Correct? So that is going to be 2.4 volt. Means 2.4 volt is a potential drop occurring across every part of the circuit. Right? So 2.4, how can I write it? 2.4, I1 will be equal to 2.4 divided by 12. I2 will be 2.4 divided by 6. I3 will be 2.4 divided by 4. How much is the answer? 0.2, 0.4 and 0.6. Is the sum of all coming out to be 1.2? Yes, it is. So that's the answer. So whenever they are in parallel and if you know the total current flowing through them, what are you supposed to do? First, take the total current, multiply it with the equivalent resistance. That will give you the potential drop across each resistor. Then again apply the formula V is equal to IR for individual resistor. Okay. So 2.4 ampere point. Right? So please make a note of this. Is that what they ask? Calculate the current and the terminal potential difference across each battery. So you need to calculate the terminal potential difference also. So calculate the terminal potential difference. How will you do that? So this cell is getting discharged and the second cell is getting charged. So for the first cell, for the 20 volt cell, what is going to be the potential drop? E minus IR. E minus I into R. E 20 minus what is the current flowing through it? 1.2. And what is the resistance value? 1. So how much is it going to be? 20 minus 1.2. 18.8 volt is the potential drop across the 20 volt resistor. Sorry, 20 volt battery. Now what about the 8 volt? Across the 8 volt, it will be E plus I into R. So E is how much? Or I'll call it as E dash plus I into R dash. E dash is 8 plus I is 1.2 into 2. How much is it? 8 plus 10.4. So that will be the value. Did you understand the difference? So one place it is getting discharged and the other place it is getting charged. So this formula is very, very important. You need to have clarity of this. Clear? Shall I proceed? This is also a good problem. There's actually a derivation. So two cells of EMF E1 and E2 have their internal resistances R1 and R2 respectively. Reduce the expression for the equivalent EMF and the internal resistance of their parallel combination when connected across an external resistor R. Assume that the two cells are supporting each other. So what do you mean by supporting each other? Means they are connected in the same manner. If you see in the parallel direction, positive, 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 everything lie in the same direction. That is the meaning of supporting each other. Okay, what is the value? There is actually a formula. This derivation I taught. If you have it in your notes, you can once refer and let me know. I've explained this. The concept of equivalent EMF of cells in parallel. Check your notes and tell me. Cells in series and cells in parallel. E equivalent, very good, is equal to E1 by R1, E2 by R2 plus so on. Right? So in this case, what will you get? If anybody has a doubt, in the pre-recorded videos, there is a separate video for this topic alone. You want, you can go and see. I'm not wasting my time of explaining it again. So E equivalent by R equivalent is equal to E1 by R1 plus E2 by R2 plus so on till En divided by Rn. This is going to be the equivalent resistance. This is the relation between equivalent EMF and equivalent resistance for cells connected in parallel. And how are the cells supposed to be connected? They should be connected in the supporting manner. If they are connected in the opposing manner, this formula will not come. You will have a minus sign. Another jagar there. Okay. So assume that now, in case this is the answer for first one, I wrote the final formula, but derivation will carry 2 marks. Okay. In case the two cells are identical, what is the meaning of this? E1 is equal to E2 if it is equal to E, and its value is 5 volt, and internal resistance of each is 2 ohm. Calculate the voltage across the external resistance when it is 10 ohm. First of all, can you draw the circuit diagram for this? So this is 5 volt, this is 2 ohm. This is 5 volt and 2 ohm. How much is this value? 10 ohm. So they're asking you to find the potential drop across the external resistance of 10 ohm. That's it, no? That is your job. Try to do it. For that, first draw the equivalent cell for it. Ram, can you come? Can you find the equivalent value for this? So what did you do? E1 by R1 plus E2 by R2, no? E equivalent, E equivalent, no, it is not 10. It will be 10 only when you connect them in series, right? E equivalent divided by R equivalent is equal to E1 by R1 plus E2 by R2. I gave you the formula here, no? This is what you're supposed to do. 5, I have to check and see. So E equivalent divided by R equivalent, 2 and 2 connected in parallel is 1 ohm. This will be equal to 5 by 2 plus 5 by 2, which is going to be 5 volt. Means the whole circuit will get converted like this. What is it? 5 volt. And what is going to be the equivalent internal resistance? Oh, you. No, I'm only trying to find for this. That is 1. So 1 means this is 10. Now you tell me. Now is it 10 by 11? It is only 11. Okay. So they are asking the potential drop across this. So equivalent resistance is equal to 11 ohm. and potential drop is 5 volt. So what is the total current flowing through the circuit? I is equal to V by R, 5 by 11. So that 5 by 11 multiplied with 10 is going to be the answer. So potential drop across the 10 ohm resistor is equal to 5 by 11 multiplied with 10. Why is it 5 by 11 by 10? Because V is equal to IR. I want to 5 by 11 into 10, that is going to give us 50 divided by 11 volt. Whatever it is, 50 by 11. I generally leave it in fractional values. Even if you leave it in fractional value, you will get marks. School exam, I'm not sure. Board exam, you will get. School exam, you check with your teacher. So 50 by 11 volt. Am I clear with this? Right? So the derivation is given here also. It's better you refer your notes and write it again. Shall I proceed? In a part of the circuit shown in the figure, the rate of heat dissipated in 4 ohm resistor is 100 joule per second. So what is the rate of heat dissipated? Power is equal to 100 joule per second. And in which resistor? It is across the 4 ohm resistor. I'm not sure if you're able to see. There is a diagram. 4 and 2 are connected in series and the system is connected in parallel with 3. So this is the diagram. Okay. Now calculate the heat dissipated in all the 3 resistors in 10 seconds. So they have given the power across the 4 ohm resistor. With that, what is it you can find? You can find the current, but the current will be the same across 2 ohm and 4 ohm because they both are in series. Right. With that, what will you do? With that current and equivalent resistance, you can find the potential difference. That potential difference will be the same across 3 ohm. Can you do that? Logic, Prida? So power across the 2 ohm is equal to I square into R. So 100 is equal to I square into 4, which implies I is equal to 5 ampere. So 5 ampere of current is flowing across the 2 ohm resistor and the 4 ohm resistor. Since I know the current across the, Since I know the current across, since I know the current across the 2 ohm resistor, will I be able to calculate one? So here when I write P4, no, it is a power across the 4 ohm resistor. So what is P2? Power across the 2 ohm resistor will be 25 into, it is I square into R, 25 into 2. 50. But they didn't ask us the power, they asked us the heat. So heat dissipated across each resistor. That's what they asked, no? Heat dissipated in the 3 resistors, not across the 3 ohm resistor. So what should I do to this 50? Multiply it with? If power is I square R, what is heat? Now, across the 3 resistors, across all the 3 resistors, you need to find the heat. So 50 into 10, that is 500 joule. Adhe mari, heat across the 4 ohm resistor is how much? They've already given the power 100 into 10, which is going to be 1000 joule. Seriya? So how much is the value of current that is flowing across the 3 ohm resistor? That I don't know. How will you find it? So how did you get the 3000? What is the value of V? V is equal to I into R equivalent. I is how much? 5 into R equivalent is 6. That is going to be 30 volt. So the same 30 volt will appear across the 3 ohm resistor also. So heat across the 3 ohm resistor can be written as V square by R into T. Very good. So V square equal 900 divided by 3 into 10. How much is this? 3000 joule. That is going to give us the answer. So the heat across each is so heat dissipated across each resistor is 1000 joule, 500 joule, and 3000. Is it clear, guys? Shall I proceed? So read this question. Two cells of EMF 1.5 volt and 2 volt and internal resistances 1 ohm and 2 ohm respectively are connected in parallel so as to send current in the same direction through an external resistance of 5 ohm. What is the meaning of that? They are connected in such a way that the intention is to send the current in the same direction through an external resistor of 5 ohm. What is the meaning of this statement? I want to know that. So that they are supporting each other. So indirectly, instead of saying they are supporting each other, they told the current is being sent in the same direction. Sorry, two cells are connected in parallel. Their EMFs are given and internal resistances are given. Will you be able to find the equivalent resistance and equivalent EMF? Can you do that and tell me? So two cells (1.5 volt) 2 volt, which is connected across an external resistor of 5 ohm. I hope this diagram is clear. Now they are asking draw the circuit diagram. Yes, we drew it. Using Kirchhoff's law, calculate the current through each branch of the circuit. Here they specific that you need to use Kirchhoff's law, or else you could have solved this problem even without Kirchhoff's law. Yes, can we do that without Kirchhoff's law? Calculate the current in each branch of the circuit. How did you get it? How is it 7.5? So 2 into 2 divided by 3. Okay. You're talking about equivalent EMF. Equivalent EMF is how much? Is it coming to be greater than 1.5 and 2? E equivalent divided R equivalent is not 3. R equivalent is 2 by 3 is equal to E1 by R1, that is 1.5 by 1 plus 2 divided by 1, that is 1. So E equivalent evlo varum? 2.5 into 2 by 3, which is 5 by 3 volt. So 5 by 3 volt is the equivalent potential difference and or EMF, sorry, and the R equivalent value will be 2 by 3. This is equal to, so the circuit diagram will get simplified like this. Can you calculate? So with this, we can calculate the potential drop across the 5 ohm resistor. Will we be able to do it? Yes. I is equal to 5 by 3. V divided by R is 15, 17 by 5. 17 by 3. 5 by 17, correct. So 5 by 17 ampere is the total current that is flowing through the circuit. So potential drop will be equal to what? V5 is equal to 5 by 17 into 5. That will be 25 divided by 17 volt. (25 by 17). Let's check if it is 1 point something. 1.47. So it is 1.4 subvolt, correct only. But in this problem, the specific with 1 point, what is it? You should not use Ohm's law, you should rather use Kirsoff's law. So I hope everybody knows to use it. Very well. Let's see. Shall I proceed? Okay, use Kirchhoff's rules and calculate the current in the arm AC of the given circuit. Where is arm AC? This is AC. On what principle does the meter bridge work? Why are the metal strips used in the bridge? So how do we proceed, guys? Can I take this current to be I? This current is getting split as I1 and I2. In reality, they will not give you these points. The diagram will be slightly different. So I is equal to how much? I1 plus I2. This I2 is flowing here. This I1 is flowing in this way. They will again get joined and the same current I will flow. So how many unknowns? 3 unknowns. How many loops are we supposed to look at? 3 loops. So what is the condition? In at least one of the loops, you should have a battery or a cell, whatever you call it. So if I take the loop AE FCA, when I go from A to E, there is no potential drop. When I go from E to F, what is the potential drop? This 30 ohm. And the current flowing through it is I1. Up minus 30 I1 plus 30 I1. If you are walking in the direction of current, means you are walking from higher to lower potential. Means you lose minus 30 I1. In the direction of current is negative. When you are going from C to A, you are walking across a cell from lower to higher potential. So plus 40. Then here you are walking in the direction of current. Minus 40 I. Sum of everything is 0. Okay. Similarly, you have AC DBA. So AC DBA, when I go from A to C, 40 I, because you're walking in the direction opposite to current, minus 40 plus 20 I2 minus 80 is equal to 0. Okay. So I have written 2 equations. The third equation, you can take the loop DEFDB. Okay. And there you can write down the equation. 3 unknowns, 3 equations. You solve it. Is it clear? Okay, they asked something. No, on what principle does a meter bridge work? It works on the principle of Wheatstone bridge. Why are the metal strips used in bridge? Why are, actually speaking, why are the thick metal strips used in the bridge? So thicker the metal strips, more will be the area. More is the area, lesser will be the resistance, because R is inversely proportional to E. So the question should have been, why are thicker metal strips used in the bridge? You did this experiment in the lab. You still didn't go. You did know. You'll have that jockey will keep sliding, will point the balance up. Meter which you'll find resistors in series and parallel. Only. First experiment is Ohm's law. பண்ணியாச்சுல அதுக்கப்புறம் மீட்டர் பிரிட்ஜ் வச்சு they'll ask பண்ணலையா ஓகே ஓம்ஸ் லாக்கு அப்புறம் they did சீரிஸ் பண்ணியாச்சுல அப்ப பாத்தியா ரெண்டு ஸ்ட்ரிப் இருக்குங்க even I think I showed you once 2 metal strips will be at the end. Those metal strips are used only to reduce the resistance because they are also conducting, if you see. That is why you'll have a slight error. Okay, I think this is last, no? So state Kirchhoff's rules for an electrical network. What are the two Kirchhoff's rules? One is KCL and the second is KVL. What does KCL state? KCL, current law or junction rule. Yes. Sum of the currents entering the junction will be equal to the sum of the currents leaving the junction, or the total current which is present across the junction is always 0. Okay. Second is Kirchhoff's voltage law, or you call it as loop rule. What does that state? The sum of the EMFs and the potential drop occurring across each resistor put in a closed loop is always 0. And what principle is it based on? Law of conservation of energy is Kirchhoff's voltage law, and conservation of charge is Kirchhoff's current law. So have this in your mind. Okay. Second is, in a meter bridge experimental setup shown in the figure, the null point D is obtained at a distance 40 centimeters from the end A of the meter bridge wire if a resistance of 10 ohm is connected in series with R1. Okay, so first part is you're able to obtain the null point at a point capital D, which is at a distance of 40 centimeters from the end A. Now, if you take a resistor of 10 ohm and you connect it in series with R1, the null point is obtained at AD is equal to 60 centimeter. Calculate the value of R1 and R2. So, initial condition, what would happen? Case 1 will be R1 divided by. So, initial case, this 10 ohm was not there. So, R1 divided by what was this value? 40. So, R1 by 40 will be equal to R2 by 60, which implies R1 is equal to 2 by 3 times R2. Let this be equation number 1. In case 2, what has happened? R1 plus 10 divided by 60. Yeah. Because AD has changed to 60, will be equal to R2 divided by balance analysis. From 160 is gone, it is 40. So R1 plus 10 will be equal to 3 by 2 times R2. So R1 substituted here, 2 by 3 times R1 plus 10 is equal to 3 by 2 times R2. Sorry, R2. Solve this, you will get the value of R2. Once you get value of R2, substitute it back here, you will get the value of R1. I hope it's clear. Shall I proceed? Calculation part leaves some gap. That's it, we are done. Okay. So R1, if you want, you can make a note of it. R1 is 8 ohm and R2 is 12 ohm. That should be the answer. Okay. Is it clear? So this is all about the current electricity paper. Moving charges and magnetism was comparatively a slightly tougher, was a slightly tough paper. Okay. See, they cannot ask for boards, they cannot ask tougher than this. Only thing you need to concentrate is the concepts of definitions and derivations. So that part alone I have not tested. For example, I did ask you the relation between current and drift velocity, because I assume that you people will practice all those things. Those derivation part I didn't ask you. Similarly, I didn't ask you to derive the equivalent resistance for anything or equivalent EMF for anything. One problem there, it was there because I felt that was important and it came. Okay. So that part you practice it. If you have any doubt, you can go through the pre-recorded lectures. Pre-recorded lectures, they are like capsules. Each topic is given individually. Other will understand. Okay. So apart from that, you have any doubt, you reach out. Okay. So that's it from my side for today. Is there any other help needed with respect to the chapters that are completed? So how many of you have exams in these chapters in the upcoming weeks? What are chapters? So I think this should help you then. Right, you also have from August or something. Same, the 3 chapters are there. First 2, then you should be able to manage them. Okay, apart from that, you need anything, let me know. Sure. So that's it, guys. We'll wind up. Those who are online, we'll wind up this. 1 minute, don't leave. Okay. We'll wind up.
Thank you.
Okay.